All right, what up, everybody? We're going to take 5 minutes of your time to teach you about series circuit VIRP charts. We're going to teach you about what they are and how to solve for the values in them. And so, first of all, a VIRP chart stands for voltage, current, resistance, and power. This VIRP is how all those quantities are um, represented in an equation. And so the VIRP chart will have V here, I for current here, R for resistance here, and P for power there. And it has one row for each resistor in the circuit. So this is a very simple example where you only have one resistor, the 4 ohm light bulb. And so I'm going to show you this example first, just so you can see how they work, and then we'll go on to a more complicated example. So first of all, we put the numbers that we see here. So we have a 4 ohm light bulb, so the 4 goes in for resistance in the R1 row, and then we have a 12-volt battery. Anything that has to do with the battery will go into the total column. Right, so the 12 goes there. Now, there's only one resistor, so the battery supplies 12 volts. The light bulb uses all 12 volts. If there's more than one, then it would split up the voltage, right? Because only one that uses all 12 volts. So we know that's 12. Resistance, the total resistance is just going to be 4 because we only have one resistor, and that resistor has 4 ohms. So now the rule is that if you have two values, you can always find a third, right? And to do that, we have Ohm's law, which says that I for current is equal to V for voltage divided by R for resistance, right? So we have voltage and resistance. We just divide those to get the current. So this says that the current near the light bulb is 3, and this 3 says the current near the battery is 3. All right, and if you need to know more about Ohm's law, we do have a video. You can click on the link to see that video. We'll keep on going. The voltage, current, resistance we have so far. Now we need to find the power. Power is equal to V for voltage times I for current. And so we have the voltage and current for the light bulb and for the battery. So we're going to multiply those together. 12 times 3 is equal to 36 for both of them. By the way, the power for the light bulb should always equal to the power of the batteries, right? If you have more than one light bulb, you would be adding those powers up. All right, so that is the simple one. Now let's go to a more complicated one. Before we do, let's talk about what happens with multiple resistors. All right, so you have your voltages across each resistor, and then you have the voltage of the battery. You would add these three together to get the voltage of the battery. And if you have more than 3, or if you have 2, then you would still add these together to give you the battery voltage. Current works differently. Current, they're all the same. Okay, so the current cannot be different in one part of the circuit than another part. All right, that works for series circuits, not for other circuits. Resistance works like voltage, where you add up the resistances of the individual resistors and gives you the total resistance. Power, you also add up the power of the individual parts of the circuit, and that gives you the total power. All right, so with that in mind, let's look at this example. All right, you got 3 light bulbs and a 24-volt battery. You put the resistances of the 3 light bulbs in the resistance column, and remember that you can find the total by adding those 3 together. There you go. You have 2 values in one row down here, and whenever you have 2 values, you can always find a third. And so we have V and R. We divide those to get the current, and that will be 3. But the current is the same everywhere, so those all have to be 3, all the current column. All right, so now we have current resistance. That's 2. We always find the third, so we're looking for voltage. So voltage, if you do a little algebra there and then move the quantities around, you get that voltage is equal to resistance times current. And if you're confused about what I did with the algebra, you can watch the video on Ohm's law where we talk more about that. So let's multiply all these to get the voltage, and then we're going to multiply the voltage times current to get the power, and there we go. All right, we completed the VIRP chart. Okay, so that's one example. If you need to see another example, we made some other videos. And if your problem that you're working on looks more similar to one of those, feel free to click on the link to the video and watch that. Hopefully this video helped, and have fun solving the VIRP charts.
Hello.
Hello, how are you doing?